All right, here is what we're going to be working on today and the things we're going to cover. We're going to hit some of the grease basics, including an overview of greases and how greases are made, what goes into them, what they're made of. We're going to talk a little bit about some of the applications and the specifications for those kinds of things and where greases are typically used. And then we're going to hit a few practical real-world things. That is talking about compatibility of greases, because that can be very important, as Tim mentioned from that anecdote, as well as storage and dispensing of greases. Things I don't know, some of that you may know, some of it you may not know. And once again, I've taken a bunch of information, tried to squeeze it down into an hour. This morning's session didn't get it to fit in an hour, so I'll try talking a little faster, but we do cover a lot of ground here. So hopefully you'll get a couple of important takeaways. There are a couple of things I'll mention them as we go along, that I think are the basics that you really should take away from today's session. So as we talk about greases in terms of our basic overview of greases, why do we use grease when oil is a perfectly good lubricant? Okay, that's kind of the first question. What's the deal with using grease when oil can lubricate something, right? Well, going to the advantages of greases include a number of things. And the first is the availability of lubricant at startup, all right? You imagine you've got a bearing here sitting still in a piece of equipment. Okay, when you first start moving that piece of equipment, you've got lubrication there. If this were an oil lubricated bearing, it might be sitting in a bath of oil that's this thick. But this whole up here is not lubricated. You know, it has to get moving to get lubricated. Or you might have to have a pumping system, pumping oil there to lubricate it. So grease starts out where you need it. That's the first advantage of grease over oil. The second is a simpler housing design. Okay, a basic grease seal is very easy to design and maintain as opposed to an oil seal or a set of oil seals if this were to be an oil lubricated bearing. You need a much more complicated housing to keep the oil in. So grease simplifies things that way. Grease can also help create a seal against external contaminants, sometimes referred to as a collar of grease that's around the outside, keep dirt or dust, physical contaminants from getting in. Grease also does a good job as a physical barrier against corrosion. Okay, I mean you got a surface of stuff on there that whatever's trying to corrode it, like a saltwater spray on the outside, prevents it from getting there. And greases can allow you to utilize solid lubricants. I've got a slide later on. We'll talk about solid lubricants and how they work. But if you try to put, and by solid lubricants I mean something like graphite or moly, molybdenum. You know, if you put them in an oil, and some people try this, the biggest problem is that they sink to the bottom of the oil. You have to continuously agitate them or have it in motion in order to get your moly suspended enough that it finds its way eventually onto bearing surfaces or between gear teeth. So nobody really effectively does a good job of putting solid lubricants inside of an oil. But a grease is another story, right? A grease, which is a semi-solid substance, you can disperse this stuff throughout the grease, and it's always there. Your moly's always available to your lubricated surfaces. Okay, so those are our advantages of grease over oil in a comparable situation. Of course, anytime you've got a list of advantages, you have disadvantages, right? So let's talk about some of the disadvantages of grease. One, and a big one, is you don't get any heat removal. When you've got something that's oil lubricated and you have some flow of oil, the oil also helps, it assists in carrying away heat. All right? Doesn't really happen with grease. And in fact, that grease, depending on how much is built up, can act like an insulator, keeps heat in place. So that's kind of a disadvantage you got to consider. Second, when you do get contaminants in your grease, they're staying there. You don't have a flushing process. Oil, some contaminant gets in the oil, you get a chance to get your contaminants flushed out. Poorer oxidation stability. this ability to resist breaking down. There's a number of reasons that greases are more susceptible to oxidation than oil, including things like to manufacture grease, you take your oil and you put it in this big kettle and you heat it up, right? You've already started the oxidation process. And then some of the chemicals used as thickeners in your grease go about and help promote oxidation. So you're already halfway or part way there. So this oxidation stability, not as good in grease as it is for an oil. And then there are over-lubrication issues. Okay? You're much more likely to run into over-lubrication problems with a grease than you are with an oil. It can be done with oils too, if you, in some cases, but it's really more of an issue with greases. And I have a slide on that later on when we talk about some of the real-world stuff. All right? For those of you who've been here before, you know I can't give a class without having a formula. All right? So we have a grease formula today. And our grease formula is very similar to some of the formulas you've seen for gear oil or for engine oil or any of those other transmission oil. You start out with a base oil, and you have some additives to improve the properties of the base oil or the performance of the grease. What's different about this formula is we also have a thickener, okay? Something that's going to give it its gel-like structure. All right, but otherwise, most greases are kind of like gear lubes. They have the same kind of base oils, the same kind of additives, but with this thickener. Now, the thickener is sometimes referred to as a soap. All right, and I will say the following, I will say you're welcome. And the reason I'm saying you're welcome is because you are now thanking me that I'm not going to give you the chemistry lesson on how to make soap and why they're called soaps and stuff like that, or we'd add another 2-3 hours to this class and it wouldn't do you any good anyway. So that's our formula, and we're going to take some time and look at each one of these 3 components that go into our grease. Okay, so the first thing we're going to spend some time with is the base oil. Okay, the base oil, this is the slippery stuff, all right? Coming out of a refinery, it is just a clean, clear kind of oil, or slightly yellowed kind of oil. And with mineral oil as opposed to synthetics, because you can use synthetics in greases, mineral oil make up the vast majority of what's in greases, okay? There's not a lot of call for synthetics in the greases in terms of the total volume of grease sold. It's a different proportion than if you look at like engine oils. You know, Mobil 1 and all the synthetic other engine oils out there represent a bigger, pretty good sized chunk of the market anymore. Not so with the synthetic oil used in greases. Mineral oil is the vast majority of it. What does make a difference is the viscosity of that oil, okay? Because you can make a grease, remember it's an oil plus additives plus the thickener, you can make a grease that out of an oil that's thicker than diesel fuel, all right, something very thin, or out of an oil that you can barely pour at room temperature, or anything in between. And you can't tell, because this is a number 2 grease, and this is a number 2 grease, you can't tell by looking at them, or doing this to them, which one has the stuff that's really, really thin, and which one has the stuff that's really, really thick. And yet, that's an important difference between greases. So that's one of the takeaways I hope you pick up here today, is that different greases, even though they're both number 2 greases, can have completely different base oil viscosities. Because in the end, it's the base oil that's doing the lubricating. So if you've got a really high-speed 10,000 RPM bearing somewhere, you need a low viscosity. That's what that really low viscosity grease is for. And if you've got something that's barely moving, slow, 5 RPM with tons and tons of load on it, then you need something that has the really heavy base oil in it to help support it while it's moving. Okay? So that's the viscosity difference story in our greases. Now you do have some greases that are synthetic, or the base oil inside the grease is a synthetic. Like I said, they're just rarer. They're not impossible to find by any stretch. You will use those, or you want to use those, where you're expecting higher temperatures. Okay, if things are going to get hot, it just makes sense to have a synthetic in there to resist the oxidation that's going to come up and to behave better at the higher temperatures. And also, where very long life is needed. Okay? In fact, you would think this is a natural for any sealed for life bearing. It ought to be a synthetic, and many of them are. But I'm constantly surprised that many of the sealed for life bearings are using a grease that's not a synthetic. It's just that it lasts a long time, but the duty is not so severe that it's creating a lot of heat. And that fighting the heat stuff is where the synthetic really kind of shines. All right, so that's our base oil. Minerals and synthetics, really mostly minerals. It's the viscosity that's important. All right, our second component are the additives. Okay, and if you've been through the automotive-related product training we had, there was, I don't know, what, a dozen almost different kinds of additives that go in to those kind of products. Greases are considerably more simple. There's not as many additives, and I've just picked out a few to highlight that we'll go through here. The first of which is the extreme pressure additives. Okay, if you remember, we've covered extreme pressure additives in a couple of these classes. These additives are the sulfur phosphorus compounds that kind of float around in the oil. And when you get some metal-to-metal contact going on between bearing surfaces or between gear teeth surfaces, something like that, little peaks on the metal surfaces start to heat up. And when they heat up, the EP additives react with it and make a sacrificial surface on the heated up parts. And so then when the next time that metal-to-metal contact tries to happen, the sacrificial surface gets wiped off and the metal gets left alone. Okay, so you're preventing metal-to-metal contact and then preventing the metal-to-metal wear through the sacrificial film that's created from these EP additives. Okay, it's working on the hot spots. That's where these additives work. Like I said, these are commonly in gear lubes, these EP additives, and greases are like a thickened gear lube in many cases. They have the same type of chemistry going on. If you take a look at greases out in the market, you know, the greases you may have on your shelf, almost all of them use that suffix EP because they have these additives in there. Okay? So that's the first class of additives, and they're in lots of places. You will also find antioxidants, again, to fight more oxidation. And like I mentioned before, your grease comes in with a couple of oxidation strikes against it, so we're going to have some additives in there to help it out. Unfortunately, unlike oil, let's see if I can make this point any better in this session than I did in the first session. If you've got a bulk of oil in an oil system and you happen to get a hot spot here, use up some of your antioxidants to fight the oxidation, but you know, you've got all these additives throughout the rest of the oil. So your overall level, it gets mixed around, your overall level of antioxidant doesn't go down very much. In grease, because grease doesn't mix and flow with each other, if you used up a bunch of antioxidants in one part of your grease, they get used up. You're not replenishing anything. And then rust and corrosion preventatives. Even though grease can help out with a physical barrier, we put in additional rust and corrosion additives to help protect metal surfaces. Okay. Further additives include tackiness additives. If you guys have been around grease for a while, you know some are stickier and tackier than others. This is done through some additives, but it's a good classic case of an additive that if a little bit's good, then more is better. The more tackiness you put in there, the more difficulty you can have in pumping it. You know, nobody wants a really tacky grease in a centralized system where it has to pump any kind of distance. It also reduces the movement of grease inside the bearings sometimes. But tackiness and high tackiness do have their place, resisting sling off and resisting water wash off. So that's all done through additives. And the next class of additives are the solid lubricants. Okay, this is the graphite and the moly There we go. We got moly and graphite and polyethylene, which is actually plastic. And these graphite and moly, these are physical solids that are in the grease. And on a molecular scale, you can see how they exist in these like plates, okay? They look like, this looks like the framing structure of a high-rise building or something like that. These plates are very firm. These vertical lines, the chemical bonds between them, are kind of weak. So when you get this stuff in between two metal surfaces and they try to move, all of these weak bonds slip. So all this stuff moves in this direction, move in this direction. And that's how we have a solid that's actually a lubricant, okay? The molecules themselves sliding back and forth because of these weak bonds. All right. And one more additive that I will mention this time, and we'll mention it again, is dye. I have another slide on it later on. We're going to talk about the color of grease, but grease color is largely governed by dye, by one's choice of what color they want to make it. And that's all I've got to say about grease additives. So we covered the base oils, we covered the additives. Let's take a look now at our grease thickeners. Okay? Yes, Joe, who can't wait until the questions part of this.
Oh, yeah, I forgot about that. I was just going to ask really quick, what does oxidation look like in a grease?
Joe is asking what oxidation looks like in a grease when it happens. You get a combination of darkening and the same kind of burned smells that you might get with, and you also, it's sometimes in conjunction, but you get some drying that happens. Things tend to get dried out. Okay, grease thickeners are the third part of the formula, and the grease thickeners are what give grease its body and its form. So what you may be surprised to learn, I know I was when I first did, this tube of grease, okay, this tube of grease has got oil in it and thickener. And it's probably got about this much thickener, and the rest of this is an oil. Okay, probably it's about 160 centistoke oil. All right, so about 10% of a typical number 2 grease is thickener. And you'd think it would be a lot more than that. This, the way thickeners work is that they are a chemical sponge. Okay, that's the best way to think of it. I mean, that's not just a good way to think of it. That is how they're working. They're working like a chemical sponge, where that little 10% sponge is soaking up all the rest of the oil and giving it its gel form, keeping it in its gel form. Okay? And the way this works, and the way we like this to work in a bearing or any other place we're using our grease, is that when the bearing's at rest, the sponge is just kind of holding the oil in place, ready to be used, right? We start moving the bearing, okay? And the grease people's term for this would be shearing the grease, because the grease is now moving inside the bearing. So when it's in motion, the oil is getting squeezed out of that sponge. So the oil comes out of the sponge, goes to where it needs to lubricate. It goes to the bearing, gets between the bearing element and the race. It gets between the gear teeth. It gets between the 2 slide plates where it needs to go. It's being released because it was shearing. And then when the motion stops, our chemical sponge reabsorbs the oil. Okay? Takes it back up, and now it's back in place, living to lubricate another day. All right? That's the magic of grease. That's how it works. Okay? Now that's the big picture. In the realistic picture, or the real world picture, not all sponges are created equal. There's difference in the different sponge chemistries, and we're going to talk about that next, the different types of thickeners. How good of a memory that sponge has, and how many times you can squeeze it and unsqueeze it, has a finite life. Things like contaminants, and whatever additives you might have used can also have some sort of an effect. So it's not a perfect sponge, and this is one of the key reasons you have to re-grease, right? That goes into part of that. But this is still the big picture. It's a sponge. It's releasing it. It's soaking it back up. That's the magic of our thickener. So let's spend some time going into a little more details about these thickeners, because there are a bunch of thickeners. A couple of them, I mean, you don't need to know every single. I'm going to present many of them here, but not all of them. And most people only need to really get comfortable with a couple of them. So let's go back into time a little bit and say you were taking your DeSoto in to the garage to get an oil change and a lube job. All right, so you go driving into the station, and Goober here comes up, and he's going to take care of you. And Goober's going to give you the lube job, and he's going to do your front wheel bearings. So he's going to repack your front wheel bearings, because believe it or not, and some of you have the age to do this. This used to be a regular practice. You had to very regularly repack your front wheel bearings. So what Goober would use for your front wheel bearings is a grease with a sodium-based thickener. Okay, you go back into that era, and he had two greases, one for the wheel bearings and one for the chassis. So your sodium grease was used for your wheel bearings because a sodium-based grease can resist heat. The wheel bearing picks up a fair amount of heat, the brakes are nearby, right? And it's got a lot of motion going on. So use sodium-based grease in your wheel bearings. Okay? But he didn't put the sodium grease, or well, Goober, maybe he did. Goober wasn't supposed to put the sodium-based grease in your chassis, on your ball joints, on your tie rod ends and pitman arms. All right, anybody know why? Yep, sodium grease doesn't hold up to water well at all. Okay? Very soluble in water. So you don't want that on your chassis parts. So he'd get out his chassis grease. Oops. His chassis grease is a calcium-based grease. Okay? Calcium-based greases are very good at resisting water. They're not all that good at heat, though. You don't want that on your wheel bearings. So it was quite a revolution in the grease business when they came up with lithium-based greases. This is your standard lithium 12 type grease, still around today. Lithium was considered a multi-purpose grease. And as a multi-purpose grease, because it did both. It handled heat as good as or better than a sodium grease, and it handled water as good as or better than a calcium grease. So you could have one grease that did them both. And as a result, lithium grew and grew in the market. By the time things were certainly in the 80s, when I was starting in the oil business, there was, 85% of the grease market, something north of that, was lithium-based greases. Okay, huge chunks are lithium 12, or the old style standard greases. All right. Now, somewhere in that era, starting in that era, they started to develop some newer grease technologies. I mean, these things had been discovered, but they were being more commercialized and made practical. And these are grease thickeners that are called the complex soaps. Okay? And if you thought you would have been bored with me explaining how grease soaps are made, how they make complex soaps is even worse. But basically, what you're doing when you complex these soaps is you're building a better sponge. Okay? You're improving upon the sponge, and in most cases with these complex soaps, what you've done is you've enhanced the dropping point. So the dropping point, the temperature, the high temperature performance of it is getting even higher than its base soap. So a calcium complex grease has a dropping point and a high temperature performance much better than a calcium grease. All right? Lithium complex. Okay, lithium complex grease, much higher dropping point than a regular lithium grease. although quite frankly now between lithium and lithium complex greases, those still occupy a huge chunk of the market out there, huge chunk. Aluminum complex greases. Aluminum complex greases have grown. We'll talk a little bit more about those. Those are real common in food grade greases these days. But aluminum complex, and in fact in this odd mix, they're used in these huge bulk quantities in steel mills, and they're also used in food grade applications in very small quantities. Aluminum complexes are great at water resistance and temperature as well. And then there's calcium sulfonate complex. Calcium sulfonate complex greases are really the current greatest thing since sliced bread. In fact, the internal name for the Fuchs version of their top end calcium sulfonate complex grease was Renault BGAT, best grease of all time. The calcium sulfonate complex greases have tremendous water resistance. Okay, really outdo anything, even without any additives for it. They got great high temperature performance, higher than, at least as high as, if not higher than anything out there, lithium complex. If you remember, we talked 2 minutes ago about EP additives, and the EP additives were these sodium phos additives, sulfur phos additives. Well, this grease is a calcium sulfonate. That same sulfur in the sulfonate works as a built-in EP additive. You don't even have to add EP additive. You add some EP additive and your EP data go off the charts. So it's a great EP grease. Plus it's compatible with a lot of greases. So it's got good compatibility. So calcium sulfonate complex does not have a huge chunk of the market now, but it's coming down the road. And in fact, part of it might end up being driven. Lithium prices are going up. Okay, lithium is used in a lot of battery technologies, right? It's going in all your Teslas and other power storage for solar. So the demand, since the demand for lithium is going up, the price of it's going up, and it's thought that it may be affecting the grease market over the next decade and having the cost of that go up. So the calcium sulfonate complexes would probably be the product to take its place. All right, so those are our complex soap thickeners. Like I said, everything's built a better sponge, works at higher temperatures. We also have a class of thickeners that are the non-soap thickeners. So these are, in a literal sense, even a little bit more like an actual sponge themselves. These are used for some different applications, but still commonly out there. Clay-based greases, made from a bentonite form of clay, absorb and hold the oil. It's very finely milled, but they hold it into a thickened state like that. They do very, very well at extremely high temperatures, right? This clay, which is a clay powder, it doesn't melt. So you actually don't have a dropping point. We'll talk about the dropping point test here in a few minutes, but basically the dropping point test, you're trying to heat this stuff up and see if it comes apart, and you just keep heating this stuff up and it keeps going higher and higher till eventually the oil burns off and the thickener's still there, right? So your limit is not on the thickener in terms of the temperature. Silica gel, you occasionally find some silica gel. This is a little more of an exotic thickener. Last I've seen it was in a food grade application, but you do find some other strange and high temperature applications where you might have this product as a thickener, it's it makes for a clear grease. And polyurea. Polyurea is kind of a unique chemical, has a couple of unique characteristics, and it's not uncommon to find a polyurea grease. Most suppliers carry one. It's got a couple of important features on it. One is that it lasts a real long time. The polyurea sponge memory is really, really good, okay? So it doesn't degrade as fast as some of the others. It's very durable, and frequently in a sealed for life bearing, this is the thickener that they'll use because it goes through that cycle so well. The other big use for polyurea grease is in electric motors. All right? Polyurea greases are formulated for use in electric motors because if you overgrease an electric motor and you blow out the internal seal, you can end up with grease in the windings of your electric motor. And your typical thickener, lithium complex or something like that, will attack the insulation on those windings. Almost all your typical soaps will, but polyurea doesn't. So polyurea is formulated into electric motor greases. Electric motor greases also don't use EP additives, those sulfur phosphorus types, because again, if those got on the windings, they attack copper and yellow metals, right? So that would be another recipe for disaster. So they don't put those in electric motor greases, the sulfur phosphorus kind of additives. And we'll talk about, I'll mention electric motors. We'll got a picture or two later on as well. All right, so those are your primary non-soap thickeners. Okay, does Joe have any questions? Or does anybody else have any questions? Yes? The question is how's the heat resistance of polyurea as a thickener, right? And the heat resistance is very, very good. It's not quite as high as something like calcium sulfonate complex, but it's not lame. Any other questions? Oh, go ahead.
On the extreme pressure on the sulfurous phosphorus, does it get absorbed when it uses as that like sacrificial layer?
Yep. Question is with the sulfur phosphorus EP additives, does it get used up as it's a sacrificial layer, preventing the metal-to-metal wear? And the answer is it does get used. Technically gets used up. The general rule is it doesn't get used up so much to a detriment that you've really reduced your capability. You'd have a hard time using it up to the point where you noticed it. Okay? Yes, sir. Okay. That's regenerative. Yeah, that does not get used up. There's at least not materially used up to the point where you would notice it during the life of that grease. Okay. So the question is with extreme impact and hydraulic hammers, the issue is the grease staying in there and getting slung out? Yeah. Yep. That is, I can. Yeah, the best you can do for that situation, a hydraulic hammer and the grease slinging out, is making sure you have something that has really good tackiness. That's about all between that and whatever mechanism is designed to seal it or keep it in place. But from the grease side of things, really tacky is probably the best you can do. Yeah. Yeah. Oh yeah. Okay. Any other questions? All right. Let's go and spend some time with grease specifications and grease tests that you run or can have run on tests. We've got a handful of them that we'll talk about here. We're going to talk about the NLGI consistency or grade. That number 2 is not just a random number 2. So we'll talk how they come up with that. We'll talk about the NLGI's quality system. We'll cover some of the most common grease tests that are run either on new grease or run at labs. I'll expound a little bit more on grease color, and then I'll offer a brief editorial on OEM grease recommendations. All right. So let's start in on talking about grease consistency, the NLGI grade. Okay, the NLGI is the National Lubricating Greases Institute. This is a trade group throughout the world. They started in the U.S. They're big in the U.S., but it is a worldwide organization. It's made up of people who manufacture grease. It's made of people who market grease. It's got grease consultants and researchers. Got an annual meeting and the whole 9 yards. And many, many years ago came up with this method of determining how goopy a grease is. It's called the consistency test. Okay, it measures the softness or firmness of your grease. And the way this works, I'll describe it now, but I got a little video to show you here in a second. This device drops this cone into a cup of grease, and you look at how far it sinks. If it sinks a lot, is the grease soft or firm? Or it's soft, right? So a big number of sinking goes to soft grease. Only a little bit of sinking means it's a firm grease. Okay, it's pretty straightforward. At least this part's not rocket science. And they have their scale. They measure how far it goes down in, and then you go over to the chart, and the chart gives you the scale that goes from 000 or triple aught all the way down, double aught, single aught, and then 1 through 6. Okay, so triple aught is the most liquidy one. In fact, triple aught and double aught greases are sold in pails with pour spouts. Okay, liquidy stuff, right? All right. Number 6 grease is another story. This, my friends, is a number 6 grease. Okay? That's an actual grease, and you are looking at a dinosaur. This is maybe the only number 6 grease in the state of Arizona and perhaps in the western U.S. Our warehouse manager called me just 2 days ago saying, "Hey, we still got this stuff over in the Mesa warehouse. Can I throw it out?" I'm like, No, it's an antique. It's a rarity. We used to have a customer who used this. I mean, they literally take chunks of this and put it in on this big open gear system, and it would go by and chew chunks of it off and lubricate it. All right, so this is a lithium grease. It's number 6. After the class, you're welcome to come and stick your pencil in it if you want, or something like that, to see what it is. But it's very rare anymore to see a number 6 grease, or a block grease is what that's sometimes referred to as. Okay, this is the device. That's where the measurement's going to come up. You saw there's the cone dropping into the cup. You saw it sank that far. And then they're going to pan up, show you on the gauge, 1/10 of a millimeter, and that gives you your penetration number. And then you take your... Anybody need to see that again? I know it's not exactly Citizen Kane, but okay. And then you go to the chart. You take the number, the penetration, and you come back and you read what your grease number is. And 90% of the greases in the U.S. today are coming in this bracket right here, because the vast majority of what you see is a number 2 grease. And that's why you see it, on your grease tubes and your kegs and your drums that you've got. That's what a number 2 grease is. Consider these descriptions are soft. Triple aught and double aught, very fluids. Like I said, they're pourable liquids. You do see we do carry 1 or 2 products available in a 3. This is kind of rare. I have never seen a 4 or a 5 called for. I've never seen it in the market in any of my years here. Say that block over there is a number 6. Until that customer, I hadn't ever seen a block grease before either. All right, so that's the grease consistency story, and that's how it's measured. It's a very straightforward kind of thing. All right. Now, our friends at the National Lubricating Greases Institute, being a big trade organization, saw that what the American Petroleum Institute, the API, had done with licensing performance characteristics of engine oils, and said, hey, maybe we can do some licensing deal for greases and set up a licensing system and collect licensing fees from the industry. So they came up with their own system to govern, or to regulate, or not regulate, to qualify grease quality. So if you may or may not have ever seen this logo on a tube or a drum or on a data sheet, this is the official NLGI quality logo. And that classification, that GCLB, is the stamp of quality and what it means. And this is the chart of what those numbers mean. Now, bless their hearts, the NLGI decided to divide things into chassis grease and wheel bearing greases. And then they set up two different quality levels for like mild duty, and this one is higher loads. This one goes mild duty, moderate duty, severe duty. My take on this is, one, I have never seen a grease that has the qualification, right? I've only seen GCLB. I've never seen anybody who paid their certification money to say, we have a wimpy grease. I just hadn't seen it. Second, you remember it was our buddy Goober who had the two greases, right? In the world of chassis grease and wheel bearing grease. So you'd think that the NLGI might have set this up in 1955, or something like that. This actually came out of the NLGI, I think, in the 1980s. I mean, long using lithium greases. But knowing the NLGI, the first subcommittees probably met in 1955. That wouldn't took them that long to get her done. Anyway, I'm just kind of riffing on that. So the takeaway here is there is this GCLB and NLGI quality classification out there. Don't get hung up on it. Don't worry if somebody doesn't have it on one grease but does on another. They just maybe chose to not register it. And it's getting GCLB does not appear to be a very high barrier based on any ones that I've seen approved. Okay, we'll talk about a few other of tests and tests that are done on grease. The first I wanted to mention, base oil viscosity. Nobody takes a grease, and well, not nobody, it can be done, but it's a real pain, so it's seldom done. Takes a grease and then try to figure out what the base oil viscosity is, right? You can do that, but you have to break the thickener and clean it up. Most grease suppliers, the vast majority, report the base oil viscosity on their data sheets. Okay, that's not difficult information to obtain. But it is important information to pay attention to, so that's why I put it up here. Okay. Dropping point. I mentioned dropping point earlier as a test method for determining how well that thickener is going to hold together under high temperatures. And this is how it's done. You've got two different representations here. You get this little metal cup. You put a thin coating of grease on the inside of it, inside of the cup. You got a thermometer that comes down in the middle, so you know what temperature it's at, and you start applying heat. You start heating this up. The first drop that falls out of here is the dropping point. Senergy employees could figure that one out. Is the dropping point. Then you read the temperature off the thermometer, and that's the dropping point. Now, your dropping point does not mean you can use your grease up to that temperature. So if your dropping point is 500 degrees, you might only be able to use it at 460, 470, something like that. The usable temperature is often quite less. But still, as a relative comparison, the dropping points of lithium complex greases are much higher than the dropping points of lithium greases. And you'll see this reported on data sheets all the time. Extreme pressure tests. Extreme pressure tests, and there's a whole bunch of them. We could spend hours going over this. The whole idea of an extreme pressure test is usually to have a test rig that's making one chunk of metal rotate against another chunk of metal, and you try to get them to weld or to scream or to make a scar of a given size, or you measure the scars under a certain weight. So there's a whole bunch of these different EP tests, but one of the more common ones, I shouldn't say most, but one of the more common ones run in the world of greases is the four-ball EP tests. And a four-ball EP test is these four little steel bearings. You hold three of them, you make a little nest of three of them, and you take one more that goes on the top. It's like held in a chuck, and it spins while an increasing load is being pushed on it. And in the four-ball weld test, when they all weld together, the machine tells you how much force was pushing down when they welded together. So, for your viewing pleasure, let's all watch the four-ball EP test. He's got the three balls go into this thing. They're nesting in there. This little collar puts them in place. You load in your grease. And you have to watch real quick for where the chuck is holding the ball when he puts it on the machine, because you can't see the fourth ball. Right there. Okay, so you put it in the machine, you get it all aligned, locked into place, You turn the machine on. Once you're in place, it starts spinning. Doesn't take long while it's adding force. There's usually some good audio as it's screaming. Sometimes you get smoke out of it. There it is. They're welded together. Okay, that little unit. And so when you saw that, and so the machine will tell you, okay, there was so many pounds or so many kilograms of force going on when those welded together. In fact, that's a good point when if you're going to compare these on data sheets. Some data sheets report them in kilograms, and some report them in pounds. So if the guy with the data sheet in pounds is going to look a lot more impressive than the guy with kilograms until you do the conversion. All right, so be aware of that. Anyway, so that's one of the more common EP tests for you there in a nutshell. And another set of tests that are worth paying attention to and that you will see from time to time are the water resistance tests. Okay? There are two of these. There's water washout and water spray off. And if you're not paying attention, you can get the two confused or be comparing one guy's washout number to one guy's spray off number. All right, so there are two different tests, and that's why I thought I would throw them in here to help reduce some confusion. All right, the water washout test kind of simulates what's going on in a wheel bearing. Okay, you take a bearing, you pack it with grease, you weigh it, find out how much you got in there, you put it into a little housing, and then you put it in this machine where it spins while water is being sprayed on it. So it's simulating it that way. Then when you're done, you take it out, you dry it, and you weigh it. How much did it lose? Okay, so that's your washout test. Your spray-off test, you take your grease, you put a thin layer of grease on a little panel, and you put it in a box, and then you spray water on it at a certain speed, or I guess certain pressure, right? And a certain pressure and a certain rate, certain temperature for an hour. You stop it, you take the panel out, you dry it off, and then you weigh it, and you see how much you lost there. Okay, so there are two different kinds of tests, and I'm going to show you each of those here. Okay, this is the washout test. So we actually have that's the apparatus, that's your bearing, and again, you've already loaded it with grease and weighed it at that point, and you assemble it in here, and you see it's not sealed or airtight. You can get into the middle areas where the water's going to try to intrude. And then it goes into, this is the little device in there where it's going to get sprayed. It's going to spin and get sprayed. It's going to get sprayed from this end over here. And then when it's done, you disassemble it, and you take it out and then weigh it. There you go. I think that's all we show on this one. The water spray off, this is the one where you're spreading the thin panel into a device. See, that's the panel. It's already got the grease spread on it. It's been weighed. Goes into this unit, and now you're going to be spraying on it for an hour at a given pressure, given volume, given temperature, all that stuff's controlled for. And this is the more severe of the two tests. These things are reported in percent, how much you lose. You lose 2% or 3% or 5% or 8%. Those are the kinds of numbers you might see. This is the one you would expect to lose, for a given grease run in each of these tests, it's going to lose more in this test than it does in the first test. Okay. All right, so those are your water tests. Keep in mind, like I said, there are two different common water tests, and don't get them confused or you do yourself a disservice there. And I mentioned earlier, I promised you we would talk a little bit about grease color. Okay? Grease color depends on your choice of dye or filler, okay? And pretty much nothing else, right? There is no industry color standardization, like electric motor greases are blue and high temperature greases are red. No, it's whatever color you want it to be, you can make your grease that color, pretty much. The closest thing that there is to a standardization, Your food grade grease is almost always white. Okay? And that kind of makes sense if you're running a really nice bakery or processing plant with all these people running around in white uniforms and you got your bearing oozing out of black grease. That doesn't look real good. Okay? Another item to note about color, if your grease has moly in it or graphite in it, your choice of color will be black. Okay? You can't dye a moly or a graphite grease and make it come another color. There is one company out there that has these additives that they say are clear moly and clear graphite. They are additives that do have moly and graphite in them as part of their chemical structure, but they are not, you remember our little plate and frame structure over here for moly and graphite? It's not that kind of moly and graphite that they're relying on to give them that so-called clear moly or clear graphite. Okay, because, all right, so that's another element. I think the bottom line, and this is another takeaway from the class, don't choose a grease on its color only. Oh, you got a red grease? Oh, that's what I use. I use red grease. Okay? All right? Grease is independent. There may be reasons there still may be reasons to stay with a red grease. You know, if you've got guys and they're trained to use red grease on these bearings only and there's no way to retrain them, you may have to, it may have to be a consideration. But don't choose a grease just on color only. All right, and now my editorial riff on OEM recommendations, on what's in the manual, because I've seen OEM grease recommendations for years. OEMs, I will graciously say, some write better specs than others. Many of them, I believe, write specs by doing copy and paste from the last piece of equipment they made, and copy and paste from the last piece of equipment they made before that. And that's why I'll open a manual from a piece of equipment manufactured in 2016, and it's recommending greases that went obsolete in 1974. Okay? That sort of stuff happens often enough. So pay attention. Hopefully you've given you enough knowledge to at least to maybe even spot something if you come up to in your manual that says something that doesn't seem right. You know, be aware of contradictions. I've seen this in the OEM recommendations, that there are contradictions into what they're saying or what they're recommending or what they're asking for. And your grease supplier, bottom line is your grease supplier can help you sort these out. I mean, I know we can, and other people have enough grease knowledgeable people that if you have an application problem, contact them. They can get you going in the right direction generally. All right, that's my thoughts on OEM recommendations. Let's talk a little bit about grease applications and places where we use grease. You guys, many of you probably know a good chunk of this anyway, where greases can be used and are used. Bearings, this is known industrially as a pillow block bearing. The type of bearing inside there could be a number of different types of bearings in that pillow block, but it is a grease lubricated bearing, and they're real common in industry. Chassis joints. Okay? Most automotive applications anymore, and for the past, I don't know how many, couple of decades, most automotive chassis are sealed for life. All right, so Goober's not doing lube jobs anymore. Okay, but trucks and heavy duty stuff, other mobile equipment do have chassis needs to lubricate. Electric motors. Okay, electric motors, real common use. I mentioned before, usually that's a polyurea grease. You can get an idea from this cutaway when we're putting lubricant into this bearing, right? It's probably coming in through this fitting here, drilled down through the machinery, going into the bearing housing. If you blow the inside seal, all that grease is going this way, migrating into the windings, and that's bad. Okay. We can also use grease in gearboxes. This is often found in very small gearboxes. Small sealed for life gearboxes can have grease in them. And so there are also some gearboxes where there's a grease spray system or injection system that's spraying grease upon the gears, particularly if it's a nice slow-moving gear. That happens. Leaky gearboxes. Okay, this is something that I came across many, many years ago as something that they used in the coal mines. This is when I was based out of Pennsylvania. A lot of coal mines would do this on like longwall gearboxes. They would leak. They're designed for use with a gear oil, but the problem is they would leak. After a while, the coal dust and coal material would etch away at the seals. And the real problem is you don't want to have to stop production just to replace a couple of seals. So what these guys would do is get a triple-aught grease. A triple-aught grease, it's pourable, but it's still quite a bit thicker than the gear oil they use, at least in its pourable form. And because the shear rate is so slow along those seals, it would be really thick near the seals. But over on the gears itself, the shear rate's higher, so it's taking this triple-aught grease, and now what the gear teeth are seeing is the base oil, right? That's what's doing the lubricating. So your gear teeth are still getting well lubricated from the base oil, but the oil, the fluid, the semi-fluid grease that's near the seals is so much thicker, the leakage rate is much, much lower. So leaky gearboxes is a not uncommon application, especially for a triple-aught grease. Trailer oil hubs, or oil lubricated trailer hubs. Okay, double-aught greases are more and more coming into play with these things. Okay, double-aught greases, again, semi-fluid. You get a good amount of additives in there, better. It's kind of a compromise between having an oil lubricated system and a grease lubricated system, because you get a semi-fluid grease and you are actually getting some flushing going on and some heat exchange going on inside your hubs. All right, a few more grease applications. Chains. Okay, chains, some people just end up gooping it on there. Sometimes there's spray systems in a more sophisticated. Oh, there's my chains picture. And fifth wheels. Everybody knows about putting grease on fifth wheels. You can imagine the best, if you really want great fifth wheel grease, you use something with a high viscosity base oil and with a solid lubricant. Those are, technically speaking, the best, but everybody knows that largely what goes on fifth wheels is the cheapest grease you can find. Right? All right, and I'll take a moment just to go over food grade applications, mostly because you just might want to know this. Not that anybody here's working in a bakery. Food grade applications, all food grade lubricants have to meet something called the H1 food rating, or the H1 rating, which, able to withstand incidental food contact. Okay, incidental food contact means you're not putting it in your food, but if it contacts your food, it's not getting anybody sick. It's not doing anything bad for anybody. So all lubricants used in food manufacturing plants have to be H1 rated. So that limits to only certain thickeners that can be used in our grease. Okay, and that includes aluminum complex and calcium sulfonate complex and silica gel. Okay, and as I said before, usually they use a white filler, zinc oxide, to make it a white grease, give it a nice white color. But the components of the aluminum complex thickener soap and the calcium sulfonate complex soap can be had in food grade capabilities. You don't find food grade lithium. Okay, any lithium ingested is a bad thing. All right, and the same thing goes for the additives that are in the grease. You don't put sulfur phosphorus EP additives in a food grade grease because those things are not available in a food grade style. You don't put zinc anti-wear in there because zinc isn't food grade, that's toxic. But you can use some of the non-zinc anti-wear additives in those applications. All right, so that's more than you wanted to know probably about food grade grease. And if you really want to, and you guys can take a look at this later if you have a chance, there's actually some little tubes of various little greases from Phillips 66 up here, and you can have your own food grade grease if you really want to go home and lubricate your blender. All right, Get yourself a tube of that. Okay. Joe, you have any questions? All right, does anybody else have any questions? Yep.
So back to the color about the grease.
Mm-hmm.
Certain manufacturers put additives there, so when it meets its service life, it changes to a different color than what it was originally.
So to make sure, your question is, are there any manufacturers that have an additive that will change color at the end of their service life? Not to my knowledge. That's a great question and a great point, but that would be a neat idea. But I have never seen that before. Any other questions? All right. Okay, let's go into as they say, the third half of my presentation. We'll talk a little bit about compatibility, because you may have heard of compatibility and compatibility issues. So this is another takeaway. I hope you go away with learning a little bit about this. And hopefully what you won't take away is more confusion than you already have. So we'll see. Okay, so compatibility is when you have different grease thickeners that don't play well together. Okay? The base oils between two different greases are fine together. The additives between two different greases would be fine together. It's all about the thickeners and them having a problem playing together. The symptoms of compatibility, or what happens with an incompatible set of greases, is one, your dropping point gets lower. Okay, you could have two greases, each one has a dropping point at 400. You mix them together, and now the dropping point is 180. Okay, lower dropping point. A change in consistency. Okay, you got a couple of number 2 greases, they're incompatible. You mix them up, suddenly it's a 1.5 or a 1. All right, so change in consistency. The loss of shear stability. Okay, gets turned around in that bearing. The bearing stops. You expect it to spring back and start, but it doesn't come all the way back. Okay, that's a loss in your shear stability. And just out and outstanding oil separation. The two greases mixed together. You come back, look at them a little bit later, and they've all run out. The oil part separated and ran away. All right. Basically, your chemical sponge falls apart. That's what happens. All these are symptoms of that exact thing happening. Your chemical sponge going apart. You may or may not have seen one of these. I have seen a lot of these compatibility charts. I will say I've seen a lot of these. I've never seen two identical ones. So keep that in mind. And the way these work, you look at the soap that you have, and the one you're wondering about, and you look at the intersection and find out that a clay-based grease and a lithium stearate grease, they got the big I, they're incompatible. Okay? Whereas calcium sulfonate grease and a barium complex grease would be compatible. Right? Like I said, these charts sometimes contradict each other. All depends on who made them and when they made them and what they meant by a polyurethanes grease, for instance. Okay? I'm not sure what they meant by that. I've been around in business a long time. I think I know whose grease they're referring to, but I can't say for sure. But these are a good starting point. Okay? These at least can give you a warning if something might be on the edge or might be questionable. So my thoughts on compatibility charts, they're not the final word. Okay? They're a good guidance, but they're not the final word. And the best way to do this, if there's a question about this, is to run compatibility tests. Compatibility tests are pretty straightforward. You get your two greases, you mix them up in 75%, 25%, 50-50, and 25-75. 3 different proportions. Get them all mixed together, and then you run some of those tests, the dropping point. You run the consistency on it. Are they changed or not? And if they're not, then you're okay. If they are, then you need to at least be aware of it. You need to know this is a possibility. Because when you switch a grease, you can do this, you still can switch greases without running compatibility tests. Okay? But what you do is you pump your grease in until you get the old grease coming out. This is easier when you've got greases of 2 different colors going on, right? you're pumping in your red grease, chasing out your blue grease. You get a pretty good idea when you got most of it out of there. So you pump till you purge, and then what you do is you increase your frequency of re-lubrication for a period of time. So if you used to grease once a month on this bearing over here with the stuff, and you do the switch over, now you go by once a week to re-grease it. And going by once a week will, one, help get more stuff flushed out, if you do this right. Okay, so you're getting more of the mixed stuff flushed out. And two, you get your eyes on it a lot sooner, a lot more frequently, to see if there's something going wrong, if something doesn't seem right, if it's running too hot or noisy or something like that. All right, so you increase your grease interval for a little while and taper your way back to your old grease interval. So that's a way of doing a conversion if you're concerned about compatibility. Grease handling and storage. Okay, I've got a number of this stuff is real common sense. I'm guessing a lot of you guys already know this or practice a lot of these things, but we'll go through them pretty quick. The shelf life of grease, probably important to know this, it's less than oil. And oil, most oils, pretty robust. I mean, we're talking, 5 years, 8 years, something like that. Oils can last a long time. Greases, not as much. If you've got a 3-year-old grease, you might want to take a look at it. One thing we can do is send a sample out to be tested and make sure it's okay, So keep an eye that shelf life on grease is shorter than oil. Another handling thing about grease has to do with the oil separation. If 6 months ago you got a drum in, you take the lid off, and you got looking on there, and you got a 1/2 inch of oil sitting around there. Or maybe the surface is cracked. It looked like they had an earthquake or something like that. Geez, is the grease gone bad? Not really. That's a pretty common aging thing. And if you just pull out your very carefully cleaned canoe paddle and you stir it back in. And you can actually do that. You can actually stir back in small amounts of oil into your grease, and you'll be just fine. But if you got this much oil sitting in the top of your drum, you've got a problem there. So that's not good. All right. So little bit okay. Stir it in. If you got so much you really can't stir it in, let's do something different with that. Okay. I put a note up here on storing tubes. This should be obvious that anybody who's dealt with grease tubes, store tubes vertically, not horizontally, because any separation you do get horizontally will work its way out of not only out of the tube, but then onto the box, onto your shelf. Storing grease guns, though, and you can go to any industrial grease guys meeting and get into a half-hour argument about the proper way to store grease guns. But I usually recommend storing them horizontally. I mean, they are sealed off, right, so you don't have stuff going out. Grease guns stored horizontally. And keep your grease dry and keep it covered. Okay, I've probably upon more than one occasion gotten a phone call from a guy who says, we had our grease out in the yard yesterday and someone left the lid off when it rained last night. Can we just pour off these 2 inches of water on top and keep using it? Well, you can keep using it. I don't know that that's a real good idea. So keeping it covered, keeping it dry, of course, best storage practices. All right, I got a few slides on dispensing grease. Grease guns, everybody's familiar with manual grease guns. A lot of guys in industrial plants like these electric ones, which makes life a lot easier. If you really like to go as high-tech as grease get yourself a ultrasonic one. These ultrasonic units, there's a rare earth magnet on the end of this. You put that on your pillow block bearing, and you get a bar readout of how much noise is going on. And you start pumping in the grease, and you can watch the noise level decrease as the grease is going into the bearing. So you know when to stop putting in grease when you get quiet enough. They also have versions of that with headsets, so you can hear what's going on as well. This is a schematic of a centralized grease system. This is the kind of system where you might ordinarily use a number 1 grease because you're pumping it, right? This is powered by plant air and going through a controller to a set of injectors, And so on a given timed interval, it triggers the injectors, it loads them up with grease, and then triggers them to release the grease into the bearing. So you set it up for once an hour to be injecting, 5 cc's of grease into your bearing, or however your standard is. So this is a nice way to do that. But it does take some understanding and some observation to know and make sure these lines don't get blocked with something, that sort of problem. The less centralized but another convenient way of getting regular grease to remote locations include auto lubricators. I don't know if you're familiar with these or had seen these. Instead of having a central line, these are put on each individual bearing. Okay, they're mounted on the bearings, and they provide a supply of lubes. You can get these things pre-filled, cases of them that are pre-filled, or you can get some that are refillable. So you just rotate some out from the conveyor that they're on. Someone goes through and does the route every 6 months, pulls back all the empties, you take them into the shop, you refill them, get them set up for next time. You can usually adjust the rates. They have a couple of different ways of doing that, but it's real common on some of these. You put in different size openings, depending on how much you want to come out. On some of the fixed ones, some of the other ones, it's actually electronically programmable. And you have a number of different drive mechanisms for these things. The real inexpensive one are spring-loaded. If you'd ever seen these, it's as simple as a plate with a plate here with a spring going up here. So you pump your grease in, and it starts pushing it out. And you govern the size of the opening to tell you how much grease you're going to get out. The biggest disadvantage of the spring-loaded ones is that spring always has pressure on that grease. And constant pressure on a grease will work to separate the oil from the thickener. All right, so that's sometimes a problem depending on the rate of grease you're using and the quality of the grease you're using, that sort of thing. There are also some, these two over here are actually one of these that are gas-driven. There's a little button up here that's got a little reaction going on, a slow reaction generating some sort of an inert gas, which is pushing down on that grease and pushing it out. Okay, less force than the spring. It pushes out just enough, it lets the pressure build back up, it pushes out some more. Again, constant rate. And then the high-tech version are the electric motors. These guys, these are programmed. These have a little battery-powered motor in here that's pushing grease at a fixed interval. You program your interval and your amount, how much is going out, and it'll feed the grease to your bearings over time. You're going to have to go and swap these out when they get empty at some point anyway. At that time, you take them back to the shop. You probably swap out the batteries too. So you have added that as part of your system, but they're very precise that way. Okay, so that's auto lubricators. Another practical grease issue thing that I like to spread the word about. In a given plant, frequently they're trying to use as few greases as possible. And you often come down to something like one grease for electric motors, like a polyurea grease, and then another one that's a general purpose lithium complex grease. And polyurea and lithium complex greases are seldom compatible, we'll just say it that way. So one of the ways to prevent compatibility issues in your plant is you put a Zerk fitting like this on all your electric motors, and you put a button fitting on all your bearings. And now your grease gun with complex has a button head, and your grease guns used for your electric motors have a Zerk head. And your chances of screwing that up are greatly reduced. Okay, greatly reduced. All right, and then I do have a note on over-greasing. A long time ago I mentioned that this was one of the disadvantages that can happen with grease. And this particular example, this is the inside of an electric motor that had one of that interior seal fails. So that's electric motor grease all over the windings in there, all right? Over-greasing is messy, creates a mess, bad housekeeping. It also is a safety hazard in a lot of places because you end up with these piles of grease, and then certainly in our temperatures, they spread due to the heat very well. Over-greasing can lead to overheating or even complicate overheating, okay, because you're churning too much grease. And excess grease around there acts as insulation. So your bearing temperatures could be getting hotter than they ought to. Then we mentioned before with our electric motor, we can do seal damage, all right? I mean, you can blow out the grease seals on any grease lubricated item, not just electric motors. And that can lead to equipment issues like what we have here with the electric motor grease. Okay, so it goes on. So if you have an electric motor and some guy saying, gee, this thing just never seems to fill up. I wonder what's wrong. Okay, get some idea that there's a over-greasing means something is not right. All right, guys. Any questions? Yes.
So does the temperature affect the shelf life?
Question is, does the temperature affect the shelf life? The answer is yes, particularly with the separation issue. Now, separation's not a whole bunch to condemn, but the more moderate you can keep that temperature, the better. Okay, it's not going to oxidize materially faster at 100 degrees than it does at 70 degrees, but the stuff coming at the separation part can become an issue. Oh, nothing's as crucial as DEF fluid. That's absolutely right. All right. Any other questions? All right, I will turn this back over to Tim.
All right. Thank you very much, Russ. Yes, round of applause. That was great work. Well done.